All right, hey everybody. In this video, we are going to learn how to make ionic formulas, how to make the actual correct ionic compounds. So this is, you are given basically the name of the compound, but you need to figure out the chemical formula of the compound, all right? And there's just a couple of things to remember when you are doing this. You're going to have a name of a cation and an anion, right? Cation and anion. Sometimes you're going to see a Roman numeral, sometimes you won't. All right? What we are going to need to do is figure out the correct electrically balanced formula, okay? The compound from the name. Okay, so the two things to remember, okay? Thing number one is that Roman numerals tell us the charge of the metal, okay? Roman numerals do not tell us how many. So just because this says iron 2 oxide, it doesn't mean that there are necessarily 2 irons. It tells us that this iron has a 2+ charge. Okay, so we have to remember Roman numerals tell us the charge. And we also have to remember that ionic compounds are electrically balanced, meaning that their pluses and their minuses are going to even out. Okay, so the amount of positives and the amount of negatives are going to be the same. That's how you're going to have a electrically balanced, electrically neutral, that's another way to say it, okay, an electrically neutral ionic compound. So these are really the only two things to remember as we're going from names to forming the correct compounds, okay? Here we go. So here's our first two examples that were on the first page. I do actually want to solve them for you, and then we'll add another one. And then off to the side, these are just our two things to remember, okay? So Roman numeral tells us the charge, and ionic compounds have to be electrically balanced. So here we go. We have sodium and chlorine, right? Sodium chloride. So all we do is we just look at our handy dandy periodic table, okay? And we have sodium, which is right here, the +1 charge. So we'll have Na with a plus, and then we have chlorine for chloride, which is right here, and the -1 charge. The first thing I would do is just write out the ions, Cl-. Okay, so just write out the ions first, and you need to make sure that it's electrically balanced. So I have 1+ and 1-. Congratulations, they're electrically balanced. I can just put them together. I have 1 positive, 1 negative charge. Everything works out. This should be just NaCl. Okay. Next, iron 2 oxide. Okay, so iron is Fe, and this 2 tells me that it's a 2+ charge. Oxide is oxygen. And in case you don't remember, it's right here, which is in your 2- charge. Again, you have a +2 and a -2. You have already, it's electrically balanced, right? I have the same number of positives and negatives. So I can just put these together in a 1-to-1 ratio. This is just going to be FeO. All right, the ugliest of compounds. Then we have magnesium nitrate, okay? So magnesium is Mg. And if you don't remember, look at your periodic table and find Mg. Here's magnesium. It's in the alkaline earth metals, so he's a 2+ charge. 2+. And then nitrate. And if you're anything like most classes, you're going to be wandering around the periodic table going, nitrate, nitrate. There's no nitrate. She's insane. Okay? Don't forget that in your ionic compounds, you can have your polyatomic ions, okay? And there it is. Right here is nitrate, NO3-. So it tells you what it is, right? You just have to look on that sheet, just memorize. Nitrate, NO3-. NO3-. Well, now I have a problem, okay? I have a 2+ charge and a 1- charge. This is not electrically balanced. And that's one of my rules that I have to follow. Okay, so if I have 2 pluses and only 1-, I need more minuses. Okay, I need another negative. So that means I need another nitrate, NO3. okay? Now I have 2 pluses from magnesium and 2 minuses from my 2 nitrates, okay? And now I can put it together. So this is going to become MgNO3, and I have 2 nitrates, right? So the way we do this is we put parentheses around your polyatomic, okay? So put parentheses around the NO3, and then you're going to put a 2 to show that you have 2 of those things. If you didn't put parentheses and you just went MgNO3 2, what this looks like is you have 1 magnesium, 1 nitrogen, and 32 oxygens, okay? Which I'm sure is not what you're trying to show. What you're trying to show is you have 2 of this NO3 group. So you put parentheses here, okay? So Mg parenthesis nitrate parenthesis 2. So 2 nitrates going with my 1 magnesium. It's electrically balanced and everything's good. On we go. So we practice some more, okay? So lead is Pb, and lead 2 means I have a 2 plus charge. Phosphate is PO4 with a 3 minus charge. Phosphate, right here, PO4 3 minus. That's just from your common polyatomic ions to know. All right, now you have a 2 plus and a 3 minus, okay? Not electrically balanced. So I need to figure out how many of each thing I need to balance it out, okay? If I add another lead, now I have 4 plus on my cations and still only 3 minus on my phosphates, right, on my anions. If I add another lead, 2, 4, 6 plus, and now hopefully you can see how this is going to go. And now if I have 2 phosphates, I have 6 minus, so this is electrically balanced. 6 plus, 6 minus. Now I can write it out. Okay, so I have Pb, and I have 1, 2, 3 of them. So my subscript tells me my quantity, right? My subscript tells me how many of them there are. Then I have PO4, my phosphate, and I have 2 phosphates. So I'm going to go PO4 and put your parentheses around it because you have 2 of those guys. All right, that's the correct formula for lead 2 phosphate. Silver oxide. Silver is Ag, always a +1, right? There's no Roman numeral to tell you, but that's okay. You will remember that Ag, silver, is one of the always +1 groups, okay? So silver has a +1. Oxide, I just left it, oxygen, is always a -2, okay? Another problem, I have a plus and a 2 minus, so I need 2 pluses. So add another silver, okay? Which means I'm gonna have Ag2 because there are 2 of them. Oh, I only have 1 oxygen, okay? The biggest mistake that I'll see on like tests or quizzes or something is they'll put AgO2. And I think that the reason this happens, right, this is wrong, so don't do this. But I think the reason this happens is because they're like, okay, silver has a +1 charge, so it's Ag with 1. And oxygen has a 2 minus charge, so it's O and a 2. Okay, please remember that the subscripts tell us how many. And the superscripts, right, up top, tell us the charge. So don't kind of conflate those, right? Don't mix and match those. Make sure that when you're getting your compound, when you're getting your formula, you're showing how many of each element is in that compound. All right, on we go. Calcium is a 2 plus, it's an alkaline. Cyanide is Cn minus. It's one of your polyatomics to know, okay? Capital C, capital N. All right. And now you can see I have 2 pluses. I'm gonna need a second cyanide to have 2 minuses. So this will be Ca parentheses Cn2. Okay, 2 cyanides for my 1 calcium. Now, one last thing okay, is about Roman numerals and why it's so important that you need to include your Roman numerals. So Roman numerals are really important, right? If I did not include Roman numerals for my transition metals or inner transition metals or heavy metals, okay, if I didn't tell what that charge was, I wouldn't know what compound I'm dealing with, right? Because both of these would be iron sulfate. But I don't know what the heck compound I'm actually dealing with unless I say what actual Roman numeral, what charge I'm dealing with here. So this tells me I'm dealing with iron 2 sulfate. So this would be Fe with a 2+ charge, and sulfate is SO4 2-. Right, there it is on your page to remember. Okay, so this is what I'm dealing with, iron 2 versus iron 3 sulfate. That's Fe with a 3+ charge, and sulfate is still the same thing, SO4 2-. Okay, the way that these are going to bond together are going to be incredibly different, obviously. Okay, for example, this 2+ and 2-, hooray, they're already electrically balanced. This is just going to be FeSO4. Not iron sulfate, but iron 2 sulfate. Okay, this on the other hand, what the heck do I do now, right? This has a 3+ and a 2-. Not electrically balanced, so I'm going to need a second iron and 2 more sulfates. So now I have 6+ on my cations and 6- on my anions. So now I'm electrically balanced, right? And this will give me Fe, and there's 2 of them, and then SO4, and there's 1, 2, 3 of them. So parentheses 3. Okay, so please notice, I would not just call this like as a name. I would not just say iron sulfate. I would have to say out loud, this is iron 2 sulfate. I have to say the name of the Roman numeral. If I don't know what compound I'm dealing with. This isn't iron 2 sulfate because there's 2 of them. This is iron 3 sulfate because this iron has a 3+ charge. Okay, so super important that you make sure you have the correct Roman numerals, that you actually study this wonderful page that has your variable cations, and that you know your polyatomics, okay? I know this was very long, but hopefully, you know, it's really just 2 things to keep charge of, okay? The Roman numeral tells you the charge, not how many, right? Iron 3, not iron 2 here. And ionic compounds have to be electrically balanced, okay? You have to have the same number of positives as you have negatives. Phew, we're done.